Okay, here are the problems you all asked for on page 261. We'll start with number 63, and it says convert the angle measure from radians to degrees and round your answer to 3 decimal places. So radians to degrees, I don't necessarily like memorizing the formula. I just like to think through. I want the radians to cancel out, and I want to be left with degrees. So I'll multiply by 180 over pi. Putting the pi in the denominator helps these to cancel. And so my answer is whatever 6.5 times 180 is. And that's 1,170 degrees. Okay, on 73, it wants us to use the angle conversion capabilities of a graphing calculator to convert the angle measure to degrees, minutes, and seconds form. So we enter 280.6 in the calculator, and then we do second apps for the angle function, and we choose option 4 for DMS and hit enter. And it gives us 280 degrees and 36 minutes and 0 seconds. So you don't have to do the 0 seconds if you don't want to. On number 95, it says find the length of the arc on a circle of radius r intercepted by a central angle theta. So that's going to be using the formula S equals r theta, where S is the arc of the circle, r is the radius, and theta is the angle. So all we have to do is remember that theta must be in radians, and it is. And then we just multiply 27 meters times 2 pi over 3 radians. I'm going to go ahead and cancel the 3, reduce 3 and 27. And so S is 18 pi meters. Number 97 gives us the arc length of 36 feet and the central angle of pi over 2 radians. And it says find the radius of the circle. So again, we're going to use S equals r theta. The main thing you need to remember about this is that theta must be in radians. So this time we know the arc. We do not know the radius, but we do know the angle. And we just need to solve it to get the r by itself. I'm going to multiply both sides by 2 over pi to clear it on this side. And so that gives me 72 over pi feet to be the radius. So 72 divided by pi is approximately 22.9 for the radius. So number 104 says a voltmeter's pointer is 6 centimeters in length. See figure. So we need to look up at the top of the page for the figure. Find the number of degrees through which it rotates when it moves 2.5 centimeters on the scale. So let me take a picture of the diagram. Okay, so I have whited out the rest of the page just so we could see the picture of the voltmeter. It says the pointer is 6 centimeters in length. So if we think about this little pointer as going back and forth as it's reading the voltage, then we know that this pointer represents the radius, so the radius is 6 centimeters. It says find the number of degrees through which it rotates when it moves 2.5 centimeters on the scale. So if it's going to move 2.5 centimeters on this scale, that's a circular movement, so that's an arc. So S would be 2.5 centimeters on the scale. And they said to find the angle in degrees. So as we go through this, we are going to have to use that S equals R theta formula again. We know the arc. We know the radius. We do not know theta. So to get theta by itself, we'll divide both sides by 6 centimeters. The centimeters cancel, and we have 2.5 divided by 6, which is 0.416 repeat. So I'm going to say 0.417. That's approximately theta. Now that's a radian measurement, but they specifically asked for it in degrees. So we're going to have to change this radian to degrees, and I need to change the radian. So I need the pi radian to be in the denominator because I need the radians to cancel. So when I do this, I believe I will just do 0.417. Actually, I'm going to use my previous answer without rounding times 180, and then I'll divide that answer by pi, and I get that theta is approximately 23.9 degrees. So all we did here is we multiplied like a multiplying fractions, 0.417 times 180 over pi times 1. So when we multiplied that out, degree is left. So it's in degrees.